Welcome to this crucial discussion on defining service level indicators, or SLIs, specifically within the intricate landscape of complex microservices architectures. In today's rapidly evolving digital world, microservices have become the de facto standard for building scalable and resilient applications. However, this architectural paradigm, while offering immense benefits in terms of agility and independent deployment, introduces a significant challenge: managing distributed complexity. Unlike monolithic applications where performance bottlenecks might be easier to pinpoint, a microservices environment comprises numerous interconnected services, each with its own operational characteristics and dependencies. Understanding the performance and health of such a system requires more than just high-level metrics. It demands granular, precise measurements that reflect the user experience. This lesson will equip you with the knowledge and tools to effectively define SLIs, enabling you to gain actionable insights into your microservices ecosystem, ensure robust performance, and ultimately deliver an exceptional user experience even in the face of distributed challenges. Before we delve deeper into the specifics of microservices, it's essential to establish a clear understanding of the foundational concepts: service level indicators, SLIs, service level objectives, SLOs, and service level agreements, SLAs. An SLI is a quantitative measure of some aspect of the level of service that is provided. Think of it as a raw data point or a metric. For instance, the percentage of successful requests or the latency of a particular API call. It's an objective measurement that tells you what happened. Building upon SLIs, a service level objective, SLO, is a target value or range for an SLI. It defines the desired level of service you aim to achieve, like 99.9% availability or request latency under 200 milliseconds for 90% of requests. Finally, a service level agreement is a formal contract between a service provider and a customer, outlining the SLOs and, more importantly, the penalties and remedies if those SLOs are not met. While an SLO is an internal goal, an SLA carries contractual weight. Our focus today is primarily on the what, the SLI, as it forms the bedrock for defining effective SLOs and, subsequently, robust SLAs. In a microservices architecture, the importance of well-defined SLIs is amplified significantly. Unlike a monolithic system, where a single application might handle all functions, microservices distribute functionality across many, smaller, independent services. Imagine an e-commerce platform where separate services handle user authentication, product catalog, shopping cart, and payment processing. If the Add to Cart button is slow, where is the problem? Is it the front-end service, the shopping cart service, the product service checking inventory, or even a database dependency? Without precise SLIs for each service, identifying the root cause of degradation becomes an incredibly complex, time-consuming, and often frustrating endeavor. SLIs act as the early warning system, providing specific, measurable data points for each component. They enable teams to understand the health of individual services, identify performance bottlenecks before they impact end users severely, and ensure that the overall system behaves as expected. This granular visibility is not just about troubleshooting. It's about proactively managing service quality and maintaining a superior user experience across the entire distributed system. For example, knowing that shopping cart service latency exceeded 300 milliseconds for 5% of requests instantly narrows down the investigation scope. When defining SLIs for microservices, we typically categorize them into 4 fundamental types that cover most aspects of service health and user experience. The first is latency, which measures the time it takes to complete a request or an operation. This is critical for responsiveness. For instance, an API call might have an SLI for its P99, 99th percentile, latency being under 500 milliseconds. Next, we have throughput, which quantifies the number of operations or requests a service can handle per unit of time. This could be requests per second for an API gateway or messages processed per minute for a queue consumer. A high throughput often indicates efficient processing. The third category is error rate, which measures the percentage of requests that result in an error. This includes HTTP 500 errors, application-level exceptions, or failed database transactions. An SLI here might target an error rate below 0.1%. Lastly, availability refers to the proportion of time a service is operational and capable of responding to requests. This is often expressed in nines, like 99.9% or 99.99% uptime. Each of these categories provides a distinct lens through which to evaluate a microservice's performance, and together they offer a comprehensive view of its health and reliability. Latency SLIs are particularly nuanced in microservices due to the distributed nature of operations. When a user interacts with your application, their request often traverses multiple services before a response is returned. This means user-perceived latency is a composite of many individual service latencies. Therefore, defining effective latency SLIs requires looking beyond just the average. While average latency can be a starting point, it often masks problems experienced by a significant portion of your users. A P50 median latency of 100 milliseconds might look good, but if the P99 99th percentile latency is 5 seconds, 1% of your users are having a terrible experience. For critical user journeys, such as logging in or checking out, we often define SLIs for higher percentiles, like P90, P99, or even P99.9. This ensures that even the slower experiences are within an acceptable bound. Moreover, it's vital to define latency SLIs at various layers: external-facing APIs, internal service-to-service calls, and database query times. For example, a user profile service might have an SLI that 99% of user profile retrieval requests complete within 250 milliseconds. This multifaceted approach helps identify exactly where the delays are occurring and ensures consistent performance for the vast majority of your user base. Moving on to throughput and error rate, these SLIs are crucial for assessing both the efficiency and reliability of your microservices. Throughput measures the volume of work a service can handle, often expressed as requests per second, RPS, transactions per minute, or messages processed per hour. For instance, a payment processing service might have an SLI to handle at least 500 transactions per second during peak hours. This ensures that the service can scale to meet demand without becoming a bottleneck. Monitoring throughput helps identify if a service is under-provisioned or if there's a sudden drop in expected traffic, which could indicate an upstream issue. On the flip side, error rate is a direct indicator of reliability. It measures the percentage of requests or operations that fail. In microservices, errors can originate from various sources: invalid input, internal service logic issues, or upstream-downstream service failures. Common error rate SLIs often focus on HTTP 500 responses, server-side errors, or specific application-level exceptions. For example, an order service might have an SLI stating less than 0.05% of create order requests result in a 5x error. Defining these SLIs ensures that your services are not only performing efficiently under load, but also consistently delivering correct results to users and other services, minimizing frustrating failures. Availability is arguably one of the most critical SLIs, as it directly reflects whether your service is operational and accessible to users. In the context of microservices, defining availability becomes more intricate because the overall system's availability is a function of the availability of its constituent services and their dependencies. A cascade of failures in one service can swiftly impact others, leading to widespread unavailability. Availability is typically measured as the percentage of successful requests or the proportion of time a service is responding correctly. It is often expressed using nines, such as 99.9%, 3 nines, or 99.99%, 4 nines. While 99.9% availability translates to approximately 8 hours and 45 minutes of downtime per year, 99.99% reduces that to just 52 minutes and 36 seconds. For a user authentication service, an SLI might be 99.99% availability over a 30-day rolling window. Achieving higher nines requires significant engineering effort and robust redundancy. It's crucial to define what constitutes available. Is it just responding to a ping or successfully processing a critical transaction? A clear definition prevents false positives and ensures the availability metric truly reflects the user experience. By focusing on availability SLIs, teams can engineer for resilience, implementing strategies like retries, circuit breakers, and load balancing to maintain high uptime even when individual components experience transient issues. While individual service SLIs are invaluable for component-level health, they often don't paint the full picture of the end-user experience. This is where the concept of composite SLIs becomes essential. A composite SLI combines metrics from multiple microservices to measure the performance of a critical end-to-end user journey. Consider an e-commerce checkout process. This journey typically involves interactions with a shopping cart service, user authentication service, payment gateway service, and order fulfillment service. If each of these services individually meets its SLI, say 99% availability and P99 latency under 200 milliseconds, but due to a complex sequence of calls or transient network issues, the overall checkout takes 10 seconds 5% of the time, the user's experience is still severely degraded. A composite SLI for the checkout completion time might be defined as 95% of checkout transactions complete within 2 seconds. This holistic view is crucial because users don't interact with individual microservices, they interact with the entire application. Defining composite SLIs requires a deep understanding of critical user flows and how different services contribute to them. It moves beyond isolated metrics to focus on what truly matters to the user, providing a more accurate representation of the application's overall health and perceived quality. These SLIs help prioritize efforts to optimize the most impactful user experiences. Now that we understand the importance and categories of SLIs, let's outline a practical, step-by-step approach to defining them for your complex microservices architecture. First, identify critical user journeys. What are the most important workflows for your users? For an e-commerce site, this might be product search, add to cart, and checkout. For a streaming service, it's login and stream video. Next, map services involved in each journey. Deconstruct these journeys into the specific microservices that participate. The checkout journey, for example, might involve 5 to 7 distinct services. Then, for each critical service, define service-specific SLIs using the categories we discussed: latency, throughput, error rate, and availability. Be precise with percentiles and thresholds. For example, payment gateway P99 latency less than 150 ms. Fourth, define composite SLIs for end-to-end journeys. Don't forget the holistic view. Establish a checkout completion time SLI. Finally, iterate and refine. SLIs are not static. They should evolve as your services and user expectations change. Regular review and adjustment, perhaps quarterly, ensure they remain relevant and effective. This systematic approach ensures comprehensive coverage, aligning your technical metrics with actual user value. In conclusion, defining robust service-level indicators is not merely a technical exercise. It's a strategic imperative for any organization leveraging complex microservices architectures. We've explored how SLIs act as the quantitative bedrock for understanding service health, differentiating them from the target-oriented SLOs and contractual SLAs. We've delved into the critical need for SLIs in distributed systems to pinpoint issues, manage complexity, and provide granular visibility. By understanding and applying the core categories of SLIs, latency, throughput, error rate, and availability, and by embracing the challenge of composite SLIs for end-to-end user journeys, you empower your teams to build more resilient, performant, and user-centric applications. Remember, the journey of defining SLIs is continuous. As your architecture evolves, as new features are introduced, and as user expectations shift, your SLIs must adapt. Regularly revisit, refine, and champion these metrics within your organization. By doing so, you're not just monitoring your systems, you're actively shaping a culture of reliability and excellence, ensuring that your complex microservices deliver exceptional value consistently. Thank you for joining us on this insightful exploration.